Welcome to the second part of SAJC H1 Physics e-learning module on dynamics. Now in this part of the lecture, we are going to introduce Newton's laws of motion and cover the first law of motion. Now let's look at Newton's laws of motion. Now on the picture on the right there, you can see that's Newton, the guy with the long hair. Now he has given us three laws of motion. Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Now, we will cover first the first law, and then subsequently we will cover the third law, and then go back to the second law. The reason why we are doing that is because it's always easier to understand the final law after we understand the first and the third law. Now, Newton's first law. Now, Newton's first law states that every object continues its state of rest or uniform motion in a straight line unless a net external force acts on it to change that state that it is in. So, to put it simply, we can say that an object at rest remains at rest as long as there is no net external force acting on it, no net force. So, if you have an object that is stationary, it will continue remaining stationary unless you have an external force pushing on the object. If not, that object is not going to move. It's just going to sit there and remain at rest. What about an object that's moving? If you have an object that's moving with constant velocity, it will continue moving in that same speed and direction as long as there is no net force acting on it. So if you want to increase its speed, means it needs to move faster, you're going to have to add a force on it so that it will pick up speed and go faster. If you want to change direction, you got to have a force that will act on it such that it will change direction, right? So as long as you are moving with the same speed and the same direction and there's no force acting on the body, it's going to continue in that same speed and direction forever unless some force acts on it, right? So let's look at an example here. We have a car that's traveling at 60 kilometers per hour, let's say, and it's going towards a brick object. Now it's going to go and hit it. Now if you assume that there is a person sitting in the car and he doesn't have any seat belt on it, what's going to happen when he collides with that object? So what happens when he hits the brick wall? Since the user is not wearing any seat belt, there is no force holding him back, so he follows Newton's first law. Initially he was moving in the vehicle with a constant velocity of 60 kilometers an hour. So when the car comes to a sudden stop, there is no force to hold the person back. He will continue moving with constant velocity according to Newton's first law, and he will fly out of the vehicle with the same velocity that he was originally traveling in. So he will fly out of the vehicle roughly at 60 kilometers an hour. Now this is what Newton's first law states, that an object continues moving at constant velocity with the same speed in the same direction as long as no net force acts on it. So from Newton's first law, we know that every object will continue its state of rest or uniform motion unless you have an external force acting on it to change that particular state. So we know that the object, if it's stationary, will just sit there, or if it's moving in a straight line with uniform velocity, it will not move unless you have a force acting on it. Now what is this natural reluctance of the body to change its state of motion. Now, we call inertia that body's natural reluctance. Now, inertia is a body's natural reluctance to start moving or to change its current motion with uniform velocity to something else. That's what we describe as inertia. Now, how much inertia does a body have? Now, mass is a property of a body which measures that inertia. So, if you have a heavier body, then it's going to have greater inertia, greater reluctance to change the motion. So, you have something as big as the Earth, you need a lot of force to be able to change that motion of the Earth. If you have a small stone, you need much less force to actually change the motion or the state of motion that the body has. So if it's stationary, you need lesser force to move the stone. If it's moving a uniform velocity, you need lesser force to actually change that motion of that stone. Whereas if you have something very large like maybe a truck, you need a lot more force to change that state of motion. So mass is a property of a body which measures the inertia of a body. So this is the end of part 2 of the 4-part lecture. Please go on to part 3 of the dynamics lecture.